Hi friends, in the last video we finished 1 to 150 questions in the video 1, and the remaining question 150 to 325 questions will finish. This is the RS KURMI engineering mechanics. We will finish with this video the whole subject of RS KURMI, all the questions we are going to finish. Okay, like this all the chapters will finish, all the subjects will finish: RS KURMI, RKJN and IES and GATE questions. 1 mark questions. Okay, simple IAS direct question, that much is enough for clearing any competitive exam of mechanical engineering. Okay, now we're going to see the first question 150 question, that is the maximum mechanical advantage of a lifting machine is, that is the maximum mechanical advantage of a lifting machine is, this is 1 by m. The maximum efficiency of a lifting machine is 1 by m into velocity ratio by r, because efficiency is mechanical advantage by velocity ratio. For maximum mechanical advantage is 1 by m, so 1 by m into velocity ratio. So that one only they writing here. The velocity ratio for the first system of pulleys, for the first system of pulleys it is how much? It is 2 to the power of m. For the second system of pulleys it is 10. So 2 to the power of n first, n for second, third 2 to the power of n minus 1. So for the third system of pulleys 2 to the power of n minus 1. Velocity ratio for the different blocks, pulley blocks, capital D and small d, diameter of larger and smaller pulley is, here down is denominator is difference will be there, 2d by capital D minus small d. Which of the following statement is wrong, he is asking. So we have to read carefully. The velocity ratio of the machine is the ratio of load lifted to effort applied. This is actually mechanical advantage, but they said this is velocity ratio, that's why it's wrong. Velocity ratio of first system of pulleys formula is 2 to the power of n. So they gave 4, 2 power 4 means it is 16. So 16 is our answer. Okay, this one already you know. Moment of inertia of a circular cross section is this one, C, that is. Next, efficiency of a screw jaw is, just efficiency is R, not maximum efficiency, so it is E. Next, maximum efficiency of a screw jaw is this one. Whenever maximum he will tell you 1 minus that one will come. Maximum mechanical advantage of a lifting machine 1 by m, that is B. Next, maximum efficiency of a lifting machine is this one. Its efficiency is asked, that's why velocity ratio also will come. Okay. Next, if the number of pulleys in a system is equal to its velocity ratio, then it is a dash system of pulleys. This is the second pulley mark. So already we know first system 2 to the power of n, 2 to the power of n minus 1 is third. N means number of pulleys, so that is equal to velocity ratio. Velocity ratio of a simple wheel axle with a D, capital D and small d diameter of effort wheel and the load wheel is, I said normally velocity ratio is 2d by capital D minus small d. So always in the ratio form will be there. Next, and the denominator should be the difference, bigger one minus smaller one. So here the diameter of the effort wheel and d1 d2 with the diameter of larger and smaller. So larger and smaller means the difference should be difference between the larger and smaller by 2d will be in the numerator will be there. So this is the velocity ratio. Okay, next, the velocity ratio of a single purchase crank which can be increased by the increasing the length of the handle. The difference, so you have to remember like this only answers for this type of questions and this type of questions, because they will copy directly from this book. Okay, the difference pulley block has the larger and smaller diameter, this one respective to the velocity ratio asking 2 into capital D, that is 100 by difference is 20, 0 0 1 1 cancel, 10 is left, that is answer. In a single threaded worm and worm wheel, the number of teeth on a worm is 50, the diameter of effort wheel is 100, the load drum is this one, the velocity ratio is 2t by capital D. So if you substitute in that formula you will get the answer, that is 164 is B, you will get 100. Next, in a wormed gate pulley block, if the number of teeth on a worm wheel is doubled, then its velocity ratio also doubled. So 2 into t. Formula is 2t by capital T. If it is, this is the velocity ratio. If it is t is double, then velocity ratio also will be double. So 165 is A. The velocity ratio of a simple screw jaw with P is the pitch of the screw, L is the length of the effort arm, is what is asking? So he is asking velocity ratio, that is 2 pi L by P. So 166 is A. 2 pi L is the numerator velocity ratio. All the steel stresses of a bridges. So bridges will be there, you know that one of their end is roller support and the other end is hinged support. The mechanical advantage of such support is that screw remains stable. So normally any support is there, one is roller will keep and one is hinge support will keep. So this is the for flexibility purpose. If any flexibility is there, it will allow the horizontal movement as well as vertical movement. But this one only allow horizontal, not vertical, because it's a pin joint type. The frame structure is perfect. The number of frames is perfect, means it is equal. That's it. The frame structure is imperfect. Imperfect means it is not equal. Then either less than or greater than. Redundant frame is also called as a dash frame. So redundant frame is also called as a imperfect frame. A frame structure as shown in the figure. So it is a triangle, it is a equilateral triangle looks like, so it is a perfect frame. A frame structure as shown in the force in the member BC. So they are asking force in the member, this member they are asking, you can apply the Lami's theorem and you can get that answer. So if you need, then I can do it. So here you can see this is the 60 degrees and this is the W. So this one you need BC. So BC into sin 60, BC into this side, BC into sin cos 60 degrees. Okay, so BC into sin 60 is equal to W. You equate vertical moments. So BC is equal to W by sin 60. Sin 60 means root 3 by 2. The 2 will go in the numerator. So 2W by root 3. So basically 2 root 3 by double 3, and this is pulling, the weight is pulling downward, so tension will be there in this one. 2W by 3W. 172 is D. A frame structure in the force in the member is the typically equal to force in the member BC. So is saying that the AC, whatever the force is there, that should be equal to the force in the member BC. So it's an equilateral triangle. So almost the same load will be there. In a frame structure shown in the force in the member AB. So AB is asking, so you have to, this is what, BC into sin 60. So BC already we got, that is 2W by root 2, root 3 into sin 60 is root 3 by 2. So it has the force in the member. It is 174 is A. It is half. Just asking what is that much. The frame structure is shown in the figure. They won't ask this type of questions. They ask whichever the 4 options is there, those questions only they will copy. Even as my knowledge, 3 options also they want to copy. So you mostly focus on 4 option questions. But for knowledge point of view, you can focus on all the questions if you have time. In a frame structure shown in the figure, the force in the member CD is tensile in nature. So CD you can see here. This is the CD, so it is pulling down. So here tension will be there. Yes, correct. 176. And frame structure member as shown in the figure. So this force I am shifting here, then it is Lami's theorem you can apply and you can get it. 176 is A. Which of the following is a scalar quantity? Scalar quantity, which one is? Speed. Speed is a scalar quantity. 177B. The rate of change of displacement of a body is called, change of displacement is called velocity. Which of the following is a vector quantity? So these all are vector quantity. Negative acceleration is called also retardation. The balls fall freely under gravity when the gravitational acceleration is taken as, we will taken as a how much, that is correct, plus 9.8. If it is going up, minus 9.1. The body is thrown upward when the gravitational acceleration is taken as 0. So it won't taken as 0, will taken as minus 9.8. The gravitational acceleration is at any place is double, then the weight of the body will be 2g. It is also a double, because W is equal to mg. Whenever this one is acceleration is double, then F is equal to ma. Whenever this acceleration will increase double, then g also will be double, then this will be 2g. Velocity of body on reaching the ground from a height, velocity v is equal to under root of 2g h. Acceleration of body sliding down on an inclined plane. I told you already, for an inclined plane, this is W sin theta. So always sin theta you will get. So 185 A G sin theta. W means mg. From there he is considering. And these are the linear equations. All are linear equations from physics we know. According to Newton's first law of motion. First law of motion. Every body continues in state of rest, uniform and straight line unless it is acted by some external force. Okay. Next, Newton's second law of motion. Dash gives the relation between the F equal to ma. This one only given. This is Newton's second law. Teachers, Newton's third law of motion is involved the studying the motion of rackets. Yes, it is justified. You can say it's correct. Okay. D'Alembert's principle basically depends on Newton's second law. Yes, correct. The rate of change of momentum is directly proportional to imposed force and taken place in the same direction in which the force acts. This statement is known as. So it's directly proportional to imposed force. Rate of change of momentum. So this is which force? Which law? You know already. You are correct. That is Newton's second law. The law of motion involved in the recoil of a gun is Newton's third law. Every action has a equal and opposite reaction. So acceleration, Newton's second law, F is equal to ma. So if it is equal to ma means here should be minus. Whenever this minus will go that side, then it will become positive. 193b. Matter contained in a body is called mass. Force by which a body is attracted toward the center of the earth is called weight. When a body falls freely under the gravitational force, it possesses a dash mass. No weight it will possess. You have to remember freely. I like that free expansion. What will be there? All the force, work, everything will be zero in the thermodynamics. Like that freely means zero, you remember. Total motion possessed by a body is called correct. Whatever you are saying, that is correct. That is momentum. Newton is defined as a force while acting on a mass of a 1 kg produces the acceleration of this one is in the direction of which acts. That's correct. F equal to ma. So mass and acceleration. Force applied on a body this much and produces an acceleration this much. So what is force applying? Mass into acceleration. 100 into 5, 500 newtons. A lift moves downward with an acceleration of this one. The pressure exerted by a man on the floor lift floor is 0 because whatever the acceleration it's coming, same with 9.8 meter per second only it's coming down. So any object is falling down, it has the acceleration of 9.1 freely. But the lift also it's now looks like it's a freely falling, so that you won't apply because your acceleration also 9.81. When the lift is moving upwards with some acceleration, the pressure exerted by the man is dash proportional to the acceleration. The pressure exerted by the man is you know already, that is directly. Next, tension in a cable lift supporting a lift is more than in a lift is moving dash with an acceleration, upward acceleration. like you are taking water from the well. So when you take water from the well with the water in the bowl, that whatever bucket, and you are pulling upward, that time the tension will be more in that rope. The tension in the cable supporting a lift moving downwards is half the tension when it is moving upward. The acceleration of the lift is 203 is D. None of these is given, but this question you mark it as some. This answer is given somewhere in the RKGN, some different answer. So just focus this question. If it is come, I think G by 2 or G by 3 is given out of these two. Just see this answer. Next, like this type of figure they will give you. This is the pulley. Here one mass they attached, some kgs. The tension is now created, and this tension will be equal tension will be there. The acceleration of the string they are asking. The acceleration of the string 204 is correct. You are saying that is A. G into m1 minus m2 by m1 plus m2. Tension they are asking. So this in place of minus into will come 2. If it is plus is there, same that. So 2 m1 m2 into G by m1 plus m2, correct. Next, the mass of the both the bodies are shown double, then the acceleration in the string. So in this formula you double m1 is equal to 2 m1, m2 is equal to 2 m2, then it will be same. If it is same, acceleration will be same. But if it is reduced 50%, then the tension in the string they are asking. If it reduce 50% is 1 by 2, 1 by 2, 1 by 2, 1 by 2. 1, 2, 2 will cancel, 1 by 2 will come outside. Here also same will be a, just use substitute 1 by 2 in place of m1, 207 SB of 2 blocks A and B 150 kg respectively connected by a string. The tension in the 3 strings dash be same. Will be same? Yes, it will be same. 208 is okay. Next, there are 2 blocks of equal mass are attached to the 2 ends of the light string. One of the block is placed over the smooth horizontal plane, while the other is freely passing over the smooth pulley. The 2 blocks will have same motion. They have same motion? Yes, because how much it will be moved down, the same will be, it will be move here. The block of 20 kg lying on a rough horizontal plane is connected by the string over a smooth pulley on another 5 kg, which can move freely in a vertical direction. The tension in the string will be dash with increasing coefficient of friction. It increases with increasing coefficient of friction. A block of mass m1, this one, m2, which moves vertically downward, the tension in the string is asking. So I told you already in the rough figure, whenever this one will come always W sin theta or whatever mg sin theta. So sin theta or sin alpha will be there. So here is a tension. Tension means 2 m1 m2. It will be in the form of multiple. Already I told you in the pulley block. Previous question by m1 plus m2. So here what will be there? That's why m1 m2 will multiple G, but denominator should be plus. So this one will be our answer, and sin theta also should be there. The angle of inclination of plane is increased. The acceleration of the system is decreases, because basically this is the body. When this one is you increase, then whenever it's come here, acceleration decrease, it's going to fall. If m1b is pulled is placed on a inclined rough plane, rough is said, so mu will come, coefficient of friction mu, and the tension in the string will be. So this one, so tension he asked m1 m2 g into 1 plus sin alpha plus mu into cos alpha by m1 plus m2. So this option also same they printed. By mistake they may be printed, so just focus. A and B same printed they are. 213. And next 214, which of the following statement is correct in connection with projectile. The path traced by a projectile in space is known as trajectory. The velocity with which the projectile is projected is known as velocity of projectile. The angle with the horizontal at which the projectile is projected is known as angle of projection. All of these are correct. Total time taken a projectile to reach the maximum height and return back to the ground is known as time of flight. Cartesian equation of the trajectory is correct. You are saying correct. That is the B. 216 is no, it's x tan alpha. First it will be this one will come tan alpha minus g into x square by 2u square into, so this one is reverse is wrote here, so like this will confuse in the exam. Okay, x into tan alpha minus g into x square 2u square into cos square alpha. Denominator cos square alpha is there and this will be second term. The path of projectile is parabola S. It will be whenever you throw some object, it will go like this, and it will fall like this, and it will make a parabola shape. Time of flight. Time of flight asking. So time of flight is equal to, you know already, 2u sin alpha by g. The distance between the point of projection and point where the projectile strike the ground is known as range. So from here you throw it and it is fall here. This distance is called as a whatever 100 meters or what, it's called as a range. Horizontal range of the projectile is u square into sin 2 alpha by g. So that is the 220 is b, u square into sin 2 alpha by g. The angle of projectile is maximum when the angle of projection is 45 degrees. So this angle 45 degrees when you throw, then it will be projectile will be more. That's why the javelin throw players, they will mostly throw in this angle, try to throw they will in this angle, then only angle of projection is maximum. Maximum height of the projectile on a horizontal plane is, so height now they are asking, u square sin square alpha by 2g, u square sin square alpha by 2g. Next question. Time of flight of a projectile on an upward inclined plane. So time of flight asking, so time of flight means u square sin square alpha by, first of all 2g, u square 2u sin alpha by, so time is asking 2u sin alpha by g, 2u sin alpha by g. So 2u sin alpha, inclined plane up he is setting. First of all 2u sin alpha where is there, 2u sin alpha here is there, here is there, but here now it is moving inclined plane up, and next time is asking. So 223 is b, so alpha minus beta. Okay, next. Time of flight of a projectile on a downward inclined plane depends upon angle of projection, angle of inclination of the plane. See here, it's also depend on alpha and beta, both it is depending. So 224 is correct, set correct. 224 is C, both A and B. The angle of projectile on a upward inclined plane, range of projectile. So range means already you know, range formula is what, 2u square into sin alpha by g. 2u square into upward means what will be there, minus will be there, 2u square sin alpha minus beta. So this is the keyword finish. 225 D. 226. The range of projectile will be maximum for a given velocity of a projectile when the angle of inclination is 45 plus beta by 2. The range of projectile on a downward inclined plane is dash. So 237 is A, less than the range of projectile inclined plane for the same velocity of projectile and angle of projection. For vertical upward inclined plane, the range will be more compared to downward inclined plane. But now we are comparing here downward to upward, so it is less. Cartesian trajectory equation, that one you know, this one. Time of flight of a projectile, 2u sin alpha by g. Horizontal range, 2u u square sin 2 alpha by g. Maximum height, u square sin square alpha by g. Next, time of flight of upward inclined plane is 2u sin alpha minus j beta by this one. Next, the unit of angular velocity is, so angular velocity, not normal velocity, that is radians per second, that is omega actually. Next, 229 b, and we call it as a revolution per minute also. We'll write omega is equal to 2 pi n by 60. So revolution per minute also sometime we'll consider. Next, 230. So just now we wrote revolution per minute 2 pi n by 60. The units of angular acceleration is angular acceleration, radian per second square. The linear velocity of a body, this one, the r is, so v is equal to linear velocity, v is equal to omega into r. Linear acceleration, a is equal to alpha into r. Alpha is angular acceleration. So 233 is b. Which of the following are vector quantities? Which of the following are vector quantities? Angular displacement, acceleration, angular velocity, all. So you focus only these three. Motion of particle round a fixed axis is as a what? Where now here is there, here one rope, now it is moving like this. So what motion it has? Obviously circular. In order to completely specify angular displacement by a vector, it must fix all of this. 236 is D, all we need. When a particle move along a circular path, its acceleration has a two component. One is normal component, other is tangential component of acceleration. That's correct. When a particle move along a straight line, there will be centripetal acceleration as well as tangential acceleration. It not be there. 238 is B. That is wrong, because in straight line it is moving, then there is no centripetal acceleration. There is only tangential acceleration will be there. When the particle move along a circular path with a uniform velocity, there will be no tangential acceleration. So 239 is A, correct. Uniform velocity means there is no tangential acceleration. The maximum displacement of a body from its mean position is called amplitude, correct. Frequency of a vibration means number of cycles per second, correct. The time taken by a particle for one complete oscillation is known as periodic time. One complete oscillation, that's correct. Periodic time of particle with a simple harmonic motion is, say, t is equal to 1 by, so this is equal to omega by 2 pi. So if you write what is asking periodic time, so then t should be equal to 2 pi by omega. So now what is the periodic time of particle with a simple harmonic is inversely proportional to inversely. 234 is T. B. 243 is B. Amplitude is always dash the radius of the circle is equal to radius of the circle. The periodic time is given by the periodic time. So that is 2 pi by omega. Just now we wrote. And the opposite of this one, if you, because t is equal to 1 by f, so this reverse is omega by 2 pi is frequency. A body is said to move or vibrate with a simple harmonic motion if its acceleration is directed towards its mean position. It's correct. 246 is correct. When a particle of velocity of a particle moving with a simple harmonic motion is dash at the mean position, velocity will be maximum. 247 is C. Acceleration of particle moving with a simple harmonic motion is dash at its mean position, 0. When velocity is maximum at that point, then acceleration is 0. When acceleration is maximum at particular point, see this is this one. When it is going up to here velocity, it will stop some millisecond and it will return back there. So this position is called the extreme position, where velocity is 0, acceleration is max. And this is called as a mean position. Here acceleration is 0, velocity is max. So this is some rope fixing here, and here some bob is there, metal ball. The velocity v is equal to omega into r. So omega into r should be come outside. So it should be square. 49 b. Acceleration of particle, omega into r, omega square into r. Here acceleration is asking. If it is velocity, omega into r. Okay, so 250 is b. Maximum velocity is now asking omega into r. Maximum acceleration, now omega square into y, like that, omega square into r. Frequency of a motion. First of all, time period t is equal to 2 pi into under root of 253 g by delta. So this is the g by delta. Now frequency is 1 by t. Now you reverse the second part, then it will be delta by, and the 2 pi will come down. So 1 by 2 pi into 253 b. This is delta by g, actually delta by g, sorry, this is delta by g. So this one will reverse, then g by delta you will get. The acceleration of a particle moving with a simple harmonic motion is proportional to the displacement of a particle from the mean position. Is it correct? Yes, it's correct. The periodic time of a one oscillation for simple harmonic motion is, periodic time asking. So 2 pi into under root of L by g, correct. Next question. In order to double the period of a simple pendulum, the length of the string should be. So if you want to double, the L should be 4L, then only 1, then 2 will come outside, then it will be, basically the quantity will be double. So quadruple means 4 times of L. The motion of body from one extreme to other is known as beat. Yes, the motion of body from one extreme to, so it is moving till here, and from here it is returned back, and it's coming here to here traveling is called as a one beat. Pendulum which executes 1 beat per second is known as, 1 beat per second is known as, that's everybody know, that is correct, second pendulum. The pendulum is taken 1 kilometer below the earth's surface in mind. It will dash in time. 159 is its gain in time. It will slowly, it will come from here to here point. Okay, the bob will come. More time it will take. The length of the second pendulum is 260 b, 99.4 centimeter. If a rigid body is suspended vertically and it oscillated with a small amplitude under the action of a force of gravity, the body is known as correct, your 261b, compound pendulum. Next, frequency of oscillation of a compound pendulum. First of all, frequency itself. Frequency means 1 by 2 pi will come, and under root of g by something delta will, like that will come. So first of all, 1 by 2 pi, where is there? That one we have to see. And the numerator should be g, should be there. So g is there here. So this should be, answer is 262 is C. So like that you can check the answers. The center of oscillation and center of suspension for a compound pendulum are interchangeable. Yes. The equivalent length of a simple pendulum and gives the frequency as a compound pendulum is kg square plus h square by h, that is B. 264 is B. So remember these answers. The center of percussion is below the center of gravity of a body and it is the distance equal to h kg square by h. So here only this one you remove, then they will get this one. Frequency is set, so 1 by 2 pi into under root of g by delta you get. So now 1 by 2 pi, where is 1 by 2 pi? So here 1 by 2 pi is there, here 1 by 2 pi is there. The g should be in the numerator. So 266 is D. Next 267. It is A. The periodic time of a particle moving with a simple harmonic motion is taken by the particle for one complete oscillation. Now match the correct following. This already you know. Velocity of a particle is 0 at. Velocity where it is 0 at the extreme ends. There it will stop. Number of cycles per second is what we call, that is frequency. Maximum displacement, amplitude. Next, acceleration of particle is 0 at mean position and velocity is maximum at that position. The motion of wheel of a car is combined translation and rotation. Important question. When a person on a bicycle drives around a curve, he has to lean dash to maintain the equilibrium inward. Okay, 270 is A. The angle of inclination of vehicle when moving along a circular path dash upon its mass does not depend on its mass. 271 B. The angular inclination with a vertical ease, what is saying? If the cycle is running at a faster speed than it is running at a slower speed, it should be less. If it is moving with high speed, so you have to bend very near to the earth. 272 is A. Angle of inclination with plane is okay. Angle of inclination is saying, so this is the cycle person and he is doing bicycling like this, and this angle should be less. If the cycle is running at faster speed than he is running at slower speed, so angle of inclination will be less. The force which act along the radius of a circle and directed towards the center, but answer is given this one. 272 is A they given, but less, it should be maintained less. The force which acts along the radius of a circle and directed toward the center of the circle is known as centripetal force. So towards the force is called centripetal force and away from the centroid it's called as a centrifugal force. So it is towards the centripetal, correct. The force which acting away from the center of the circle is called centrifugal force, correct. So 274 A. The slope on a road surface generally provided on the curve is known as angle of banking, that one you know. 275 is C. The ideal angle of the banking provided on the curves on the roads depends upon the what it is depends. So 276 is B, velocity squares of the vehicle. So the banking formula down we'll see, then you can understand. The train is a round curve. When a train is round curve, the side strut on the wheels plane is provided by the rising the outer edge of the rail. Yes, correct. That's correct. It's correct. Amount by which the outer edge of the rail is raised is known as super elevation. That's correct. In railways, the super elevation expressed in the terms of distance between the two rails is correct. Super elevation is given by the V square into, so this is 280 is C, G into V square by G into R. So what you have to remember, how you remember super elevation, capital G, same below small g. Okay. Maximum velocity of a vehicle in order to avoid the overturning. Very important question these are. Avoid overturning, not skidding. Overturning on a wheel circular path is That one, whatever you are saying, that's correct. 181, 281 is D, under root of. So velocity is under root of 2gh. You can remember like that. Root will be there, but the h will be not in the numerator, it should be in the denominator. Next, a vehicle moves on a level circular path. The reaction at the inner wheel is. Reaction at the inner wheel is. So 282 is correct. Whatever you said correct, that is mg by 2 into 1 minus v square into h by g into r into e. Okay, you should remember this one. So mg by 2 will common, 1 minus will be there, v square into h and g into r into a will be in the down. Maximum velocity of the vehicle in order to avoid skidding now. Skidding also under root of mu gr. Overturning you know already, this one. Overturning also under root. Skidding also under root, 283. Okay. The overturning of a vehicle on a level circular path can be avoided if the vehicle, if the velocity of the vehicle is dash is less than. The overturning should be less than. The skidding of a vehicle on a level circular path can be avoided if the force of friction between the wheels and ground is greater than the centrifugal force. If it is more, then grip will be more, then he won't fall. Total movement of a system of masses in any one direction remain constant unless external forces in that direction. This statement is known as Newton's first law. The bodies which rebound after the impact are called as elastic bodies. Loss of kinetic during the inelastic impact is given by the. That's correct, whatever you said. m1 m2 by 2 m1 plus m2 into u1 minus u2 whole square, not inside square, it is whole square, and here u1 u2 only inside, m1 m2 m1 m2, here 2 will be there. The impact between the two lead sphere is approximately equal to dash in elastic. In collision of a elastic body, the collision of coefficient of restitution is the ratio of the relative velocity after impact to relative velocity before impact. Correct. The coefficient of restitution for the inelastic bodies is, so 291. 291 is A, 0. Because what we said, V2 minus V1 by U1 minus U2. So this is the coefficient of restitution. So what will be there? Coefficient of restitution for inelastic bodies. Inelastic bodies, what will be there? Here some sphere is there, here one more sphere is there. When it is hitting this one, what will happen? They won't change any momentum. There is velocity is both will be this body will be in the rest condition, and this will be also in the rest condition. So there is a velocity is 0. They won't rebound and they won't move in the far away. So here this spot is 0. So it is 0. The coefficient of restitution for the elastic bodies is 1. Yes, it's 1. 292. Actually, he didn't use here word perfect. He has to use perfect in elastic bodies. Then it is correct. Otherwise, it is wrong. During elastic impact, the relative velocity of two bodies after impact is dash the relative velocity before impact. Elastic impact is said, so equal and opposite. The loss of kinetic energy during the elastic impact is 0, as there is no loss of energy. Loss of kinetic energy due to direct impact of two bodies dash among the values of coefficient of restitution. So it's a depend or not depend. So 295 is as it's a depends. Which of the following statement is correct? Kinetic energy of body during impact is remain constant. So like this, every statement you have to read. But the correct answer is kinetic energy before impact is equal to after impact. Okay. Two elastic balls collide with each other, and these all the statements are correct. Two balls of equal masses, perfectly elastic material, are lying on a floor. One has the mass of velocity made to strike the second ball. both the balls after impact will move with a velocity. So that one you can calculate u1 m1 plus u2 m2 is equal to m1 v1 plus m2 e2. So you can substitute in this formula two balls of a equal mass. So m1 is equal to m2 is equal to m. Lying on the floor, one ball of with a velocity v. So u1 is v, you said. I have to struck the second ball, and u2 is 0. Both the balls after impact, they will move with the same velocity. v1 is equal to v2 is equal to some v. Then substitute these values. mv is equal to v is common, so v will come outside 2 m v. This is some another velocity. See, this is v1, this is some u, this one is some u tried, this is some vu, right? So mm will cancel, so u by 2, v is equal to u by 2, that is a v by 2. Okay, 298 is b. 299, a lead ball with a certain velocity is made to strike the same ball. Reason for this following: the change in moment suffered by the rubber ball is more than the lead ball. So 299 is b. So coefficient of restitution formula you know already, v2 minus v1 by u1 minus u2, very important formula. Body moving with constant velocity strike another body of mass m moving with the same velocity but in opposite direction. The common velocity of the both bodies after collision is, that is b, 2v, because in the opposite direction they will be added. The rubber ball is dropped from this side. If there is no change of velocity after rebound, then it will be rise to up to 2 meters. Whenever a force acts on a body and the body undergoes a displacement, then work is said to be done. Displacement means work is said to be done. Correct? Yes. The unit of work in SI unit is joule. 1 joule is equal to 1 Newton/meter. Work is said to be done when the some force act on body but displacement is 0. Force is 0 is it. So force into displacement, out of these two any one is 0. No force act on the body, some displacement takes place, either A or B. 1 joule means 1 Newton force and displaced by a 1 meter, because 1 joule is equal to 1 Newton/meter. Joule is the unit of, you can write either work or energy. So energy will take both the given. The rate of doing work is called, it's called power. The units of power in SI units is, it's watt. 1 watt is equal to joule per second, 1 joule per second. Power developed by the body acted upon by a torque T Newton meter and it is revolving at omega radian per second is given by, it's given by, that one is already you know, that is power is equal to T into omega, tau into omega, T into omega, torque into omega. Energy can be defined as the capacity of doing work. Yes, correct. Units of energy in SI units is energy possessed by body for doing by virtue of its position. Its position means potential energy. Kinetic energy of body dash upon mass and velocity. Kinetic energy is half mv square, so it depends on mass and velocity. Potential energy stored by a spring in compression is called as strain energy. It's called as strain energy. 317. Yes. When a body of mass attains a velocity v from a rest in time t, then the kinetic energy of the translation is half mv square. So half means 0.5. So 318 is C. A body of mass moment of inertia I, so half I into omega square. So this is T. Wheels of a moving car possess kinetic energy of rotation and translation both. According to principle of conservation of energy, the total movement of a system of position in any direction remain constant unless upon acted by the external force in that direction. That's correct. No. Conservation of energy is not this definition. Okay. The total energy possessed by the system of moving bodies. The total energy possessed by the system of moving bodies is constant at every instant, varies from point to point. Total energy is said, so is constant every instant. Okay, so 322 is A. Potential energy of a vertically raised body is equal to the kinetic energy of vertically falling body. When the spring of a watch is wound, it will possess correct strain energy. If the two bodies having a mass m1 m2, m1 is greater than m2 having the equal kinetic energy, moment of the body having the mass m1 is greater than the m2. So momentum is depend on the mass, so which one is having the more mass, that one will has the more momentum. So like this we finished all the 325 question. In the next video, now we finished all in these two videos we finished RS KURMI, engineering mechanics, all 325 questions. Okay, like this I will finish remaining all subjects. In the next video I am going to finish strength of materials, two parts again. Half questions will be in one part, next half will be in the second part. Like that I will finish all the RS KURMI, then RKGen, then IS direct questions, and then get 1 mark question and some simple question as the following type questions is there. Then that one will be helpful for you any competitive exam, and that much is enough for any to clear any competitive exam. Okay, all the best. Thank you.